Okay, so again, welcome back, episode 11. It's been great to see all the comments. It's fantastic. The new subscribers. So just to let you know, when you hit, I think, 1,000 subscribers on YouTube, you get a choice to monetize the channel, which I did. Now, it doesn't make any difference, at this level of viewership, but the option was there, so I hit it. So if you're seeing ads, you should be able to skip them. I do apologize, but look, if it makes a few dollars, all the better. Um, Now it's actually a fairly weird process because when you post a video on YouTube, you have to tick whether or not it's made for kids. Now, my interpretation of a child is someone below 18, which is kind of a shame if the parental guidance is turned on their device, if they're watching and they're like, 16 or 17 and they have a keen interest in engines. But I tick not for kids. So it's a bit mad, like there's nothing X-rated in these videos. There's no bad language yet. Um, but I think it's a shame in some ways that it's just done like that. That you could set an age because, like, the 14 or 15-year-olds that are going nowadays, like, geez, some of them would run rings around you, in terms of what's out there on the internet and what they see. But that's how it is. So that's just a brief rundown on how the channel is going. I didn't expect it. I've got, I think, the subscriber levels have doubled in the last week. So I've got another 1,000. So to everyone that has shared the videos or subscribed or told people about them, thanks a million. It's great. So onto this video. You'll be delighted to know that, unlike episode 10, there'll be no there'll be no carpentry lessons or mention of woodwork in this video. So you'll probably be delighted. We're back to hardcore Formula One again, and this is going to be based on what I would call the dry sump system of the Formula One engine, and basing it solely on the scavenging methods of all the areas in the engine. Now, a comment came up, I think it was yesterday at about lunchtime, of why the comment was of, I think, why the timing chest where all the gears sit, why doesn't that fill up with oil if the gears are getting oiled and it's all dropping down at the bottom? Now, I think one other guy saw that there was a little oil way out of the timing cover in the sump girdle, but it's not clear where it went. So that's what I'm going to dive into now. Let's do it. Like, you could glance over. There's many videos on YouTube where people just glance over, all the oiling system of an engine. It's this, this, and this. But let's really break this down. This is what this series is all about. Breaking it down to small details, going into as much detail as I can without, really going overboard. Um, so I'll do another video on the main, what I call the pressure oiling system of the engine later on. But for this video, let's just start on the scavenge system. So, as many of you know who are watching this channel, your road car or normal road cars have just a conventional oiling system where all the oil is stored in a sump in the bottom of the engine. That's your container for the oil. There'd be 4.5 liters in there. It gets pumped around, it drains down into the engine and back into the sump again underneath the crankshaft. But that has its problems because in a race car or a Formula One engine, that oil, like, takes up room, number one. Keep in mind, with a Formula One car, the crankshaft is quite near the ground, so you want the crankshaft and the entire engine as low as possible in the car for lower center of gravity. Plus, it's set in the rules. The crankshaft has to be a certain height over the road or over the plank, as that's the reference. Years ago, it actually used to be a plank, which is the piece along the bottom of the car, but I think now it's some sort of phenolic glass fiber resin plank. But there is still a datum plank on the bottom of a car. And so, with that in mind, there wouldn't be room for a huge sump underneath the Formula One car. And also, if you have a lot of G-forces, which a Formula One car has, that oil is all sloshing around in the sump and it's splashing up into the crankshaft, which sucks power from your end result of horsepower, because when it sloshes into the crank, it actually slows down the crank rotating, would you believe it, when it's splashing through the oil. So with Formula One or race cars, they go with what's called a dry sump system, where the oil drains down from the bottom of the engine, or should I say all through the engine, down to the bottom in a really shallow sump pan, which is in this case the ladder sump, which we've covered kind of in a few videos before, and it's then sucked out of that, pumped into a de-aerated, which, as you can imagine, when the oil falls down through the engine, it gathers some air bubbles after being through hell, let's face it, at over 700 horsepower. So it does pick up some air. So you need to get the air out of the oil before you pump it back into the engine again, because as you all know, if you pump oil with air in it, you know it's not. It doesn't create an oil film, the hydrodynamic oil film in plain bearings, and that's bad. So you need to get all the oil, or all the oil out of the air, or the air out of the oil, whichever you want to say it. So a dry sump scavenge system does that. So what we'll do is we'll have a look at some photos of cutaways of the engine, have a look at the parts, have a look at some CAD, and walk our way through it. Now, with Formula One engines, they're all pretty much, like, I don't want to cover too many boring details. I would consider a Formula One scavenge system pretty much normal, but let's run through it anyway. Now, there is a few clever things done with the Formula One system, which wouldn't be seen as much in, you know, like a rally car or an all-out race car, but let's cover it anyway. Now, again, I've very few parts on the table here. You've seen this part before many times. You haven't seen these parts. This is a needle bearing. This is just an Allen key. But so getting back to why this video is being made, one user said he couldn't understand why the timing chest fills up with oil and how the oil is taken out of there. So let's dive into that now. So I'm going to take away these for 1 sec, and we'll bring them back in again in a minute. So a quick look at a normal Formula One scavenge system, which is this engine here. Now these parts are the rotors, which you can see there. So that's one rotor, it's that part there. So there'll be 1, 2, 3, 4, 5, 6 of them. Now these are roots type rotors, which you'll all recognize, or hopefully some of you will recognize. So these run in mesh like this. The gears are kept on the end there and keep them in timing. So when they turn like that and they run together, creating a positive displacement pump. So there's been many pumps like this over the years, like from superchargers to water pumps, air pumps, all different sort of things like that. So that's how they would sit there in mesh in the various sections. Now these are slightly different to a race car in that they're, number one, they're very light. You can see the little grooves here as well to keep the film going, the oil film going. Keep in mind these are running in the housings, which I'll show you. You can see the housings here, they're each compartment. So they run very tightly into the compartments. In terms of the noses here, they've got dividers then, which are aluminium pieces which locate on either side here, and they're slid in, and the whole unit is built up. So they're like partitions, if you want, just to separate out the various pockets, which in turn are these pockets here. So you have 1, 2, 3, 4, 5, 6, 7, 8 pockets in total. So we'll run through what all those are on the CAD, how the heads get scavenged, how the timing chest gets scavenged, and the crankshaft as well area gets scavenged. So let's have a look at the CAD. This is a very nice cutaway, by the way. It's one I found online many years ago. I'm not sure who took it, so I can't give copyright issues. Now I did steal it, I'll admit that, but I think it could possibly be Cosworth's press photos. They were all over the internet at the time. As it happens, I can't find any now, but I've saved these, I think, about, I don't know how many years ago, a long time ago. So it might have been Matthew Grant that took them, that works in Cosworth, I'm not sure, but that's where I got them. it makes it far easier that you can see the actual parts on the actual engine, because I'm not going cutting my own pump like that, obviously. And with the CAD, I don't want the channel to turn into a CAD only channel, because I've watched channels like that before, and it can just get a bit boring. If you're looking at CAD all the time, it's a bit monotonous after a while, You're thinking, Jesus, is this guy, is this all this is going to be, just a CAD model? But so I want to keep a bit of variety, is what I'm saying. So we'll come back to this photo again in a minute, and let's have a look at the CAD. So back to the old trusty CAD again. Now again, this is the sandbox CAD, which you've looked at before. It hasn't actually been closed since, and hasn't crashed miraculously. So let's turn off the exhaust and just concentrate on the area that we want. Yeah, that should be all we need. So let me have a quick glance and see if there's any glare. No, we're good to go. So going back to that photo again, you can see the dry sump scavenge sections here, which are these ones here, which I've scanned, CMM'd and probed off my own sections, so they're all the same, Now one thing I don't want to turn on here is the manifold, because I have the real part here beside me. It's not in storage, it's right here. So you can see where the ports are all here. So you have 1, 2, 3, 4, 5, and the same on this. So that bolts on there like that, and the scavenge manifolds then will bolt onto that. Now there's one turned off here, there'll be another one there. And let's go to another photo just to show you how it looks in plan view. So this is my actual engine. So you can see the sump. This manifold is here like this, sits like this. You've got the various sections where the roots blowers or the roots scavenge sections sit in like that. 6 of 3 pairs. And these are the windows to take in the oil and air mist here. And these are the pipes which go to the cylinder heads, which have their own scavenge sections. So we've got 5 along there, 2 here, and we've got another one which I'll show you in a sec. So going on to some other pictures just to show you how these work here, that it scavenges from the heads as well. Now the fact that this engine is a V engine, it's kind of ideal for scavenging out of the head, because with a normal road car your engine is normally sitting fairly level. Say in an inline 4 front wheel drive or rear wheel drive, the cylinder head is sitting fairly level, or sometimes canted over at 15 degrees. So the oil doesn't run that urgently to one side of the head, so it can make scavenging from the head a little bit more difficult. But in the case of a V engine like this, it makes it a bit easier. So let's just flick through where we are. Yeah, so you can see the engine here. Now this is the PTO side of the engine, which will be the power takeoff side. The gearbox is on this side. You can see these pipes again here. They come up here. One goes to the left bank, so that takes the oil from there and air mist out of the head. And one goes to the right bank, which is here, this one here, and again down. There's a joiner in this pipe here. So if I go back to my own head, you can see the joiner here, and this will be the cylinder head on that side. So that sucks oil from that and air. So these all travel on these pipes. These are carbon fiber. They're biaxial weave, and there's all different types of weave. I want to cover carbon fiber pipes after a while in another episode. The water pipes are actually done this way as well. So let's just do that in another episode, because that's one in itself, how they make those. Now you're probably wondering why they didn't just put a channel down from each head, and each head down here, which is common in most race cars. You just put a channel down from the head, which drains down in here, and it gets evacuated then in each section. That's not a great idea, because as the oil is running down from the head, it bashes into the crankshaft, which slows it down. So you really want to be keeping the oil from the head separate out of the crankcase and on its own remote, remote ways or lines. So let's go back to these photos again. So as mentioned, they're the pipes that evacuated out of the heads. If we go on, you've seen that, that's the pump. Now the pump is driven with just a hex shaft like this, just like an Allen key. It's driven in here from the timing chest. There's a drop gear here, and they're all driven then independently with a big long, I think it's an 8mm hex shaft, which would be a tool steel or high grade steel, M500 or whatever steel you want to guess. So they all drive at the same speed. They're running in cast aluminium housings, which is fine. Like so is the camshaft. You can go direct to the aluminium that way. There's plenty of oil in there, like, you know. These are positive displacement, keep in mind. So they're pumping out. So there is a pressure delta, so that there will be a bit of oil pressure here. There's also little vent holes, which I can hopefully show you in the CAD, which allows the oil in here and out again. And I'll show you that in the rotors too. Now the oil, once it's pumped out here and the air mix, it travels along here. Now, very important to keep in mind, these are positive displacement, not like your normal, you know, like let's say a vacuum cleaner, whereas you can put your hand over the end of the hose and it'll just, you know, not do anything. You can't put your hand over the end of a positive displacement pump. It'll just blow it off. It'll just keep pumping. They're designed for shifting air and fluid. So the oil air mist travels along here, and it goes into what's called an oil air separator, or I've heard them called different things, a deaerator, or there's various different names, but like it's called, in reality it's a centrifugal or centrifugal, depending on where you're from. I've said that before, but I've heard it called a few different things in the States especially. But it just works by G-force. So when the oil comes in here into the middle of it, it flings the oil out. Because the oil is the most dense particle in the mix, it flings the oil out to the outside into an involute casing. So the oil then is on the outside, it's on the perimeter of this case as it's turning, and the oil can travel away back into the oil tank, and the air then exits the center. It's like if you've ever seen like when you put on your washing machine, when it's on its spin cycle, when it finishes, what that's doing is it goes way up in RPM, and the water is driven out of the clothes because it's more dense than air. So it flies to the outside of the drum, into the outside drum outside that, which is coaxial to the inner drum, and it drains away. The pump then drains it away. Again, same with, you know, even a salad. You've seen the things, you put the salad into the basket and you spin the handle and it dries your salad, and the water then collects in the bottom. Same principle exactly. So that is how that works. Now, let's just skip on. The oil pump itself is nothing special, so I probably won't cover it too much in detail. It's the same, you know, going back to the Mark 1 Golf. It's just two spur gears running together, and that just provides pressure. Again, driven by all the gears in the timing case. This one comes out here, torsion bar driven again. Everything is torsion bar driven in a Formula 1 engine, just to cut down on torsional harmonics, don't forget that. And it just pumps the oil. Nothing special there. I have gears and the pump and all that. I'll show you in the next episode, but it's nothing special. So let's go on here. This is that same oil pump housing. The oil filters here. So again, same as your car, you take off this, you can take out the filter, throw it away, put in a new one. Now I wouldn't say they'd be changing these filters much, because the engines only last like 1500 kilometers, but it has to be filtered. Now that would also help to deaerate the oil as well, because if you put a fluid with air in it through a filter system, it will naturally try and collapse or break the bubbles that are inside it. So that's the kind of the last resort of separation. Plus as well, you've got the cyclones in the oil tank up here, which if you go back to the oil tank video, I think it was number 2 or 3, you'll see what that's about. When it's gone in, it separates them out, like I won't mention what brand Hoover, or a sawdust cyclone. So again, this is the involute from the oil air separator here. So the oil enters again the engine here, comes down to a drilling, which I'll show you in a moment, and goes back to the oil tank here, and the air would exit here. So what else have we on that while we're at it? Nothing much there. Again, this is the oil tank. You can see one of the cyclones here, and that's kind of an overview. You can probably see this better here, the involute and the Scavenge rotors, tank, all the rest of it. Is there anything else while we're on that photo? There isn't, no. So let's go to the CAD. So this is the CAD of what you've just been looking at. So now again, I've turned off a load of parts. This is the sandbox model. And if we zoom in here, so the thing with the Formula 1 engine is, or with any engine, or any mechanical part, be it aerospace, be it Formula 1, whatever you're doing, you know, in your own workshop or your own career, is to try and cut down try have the maximum amount of parts as minimum as possible. Just because you're cutting out failure rates. And there's a lot going on here with the Formula 1 engine in that respect, and with aerospace. You know, even medical as well, there's a lot of they look like shortcuts, but they're actually there for a reason. They're to minimize risk and failure modes. So like where the oil exits the separator to go back into the engine again, like many people would have put in a pipe or put in, you know, a fitting or something, or O-rings, but instead they went with a drilling through the girdle itself, just to minimize parts. Now the machining, alright, is tricky, but it minimizes a lot of failure modes, as I said. So if we do a section analysis on that, we can see the return parts for the oil. So again, in terms of machining, crazy. So the oil would return back here, go down a drilling here. Now, in fairness, this would be a core and a casting, but this is machined, so is this. If I go down a little further, so you can see now this drilling here, which is the exit, goes down here, and meets this drilling. So I'll just show you that again. In, down, out, up, and out to the oil tank. So that's pretty cool. Again, sealed with an O-ring here and an O-ring here. Now if we turn on the timing cover, I'll just show you that interface while we're here. I have to check the time now in a second. It feels like we're running up in about 20-25 minutes. Let's turn on the timing cover. Yeah. So again, you can see where that comes out into the timing cover. Now if I turn off the block, or the girdle, should I say, let's turn off this. And turn on the timing cover. I should really get a mouse for doing this. Here we are. So that's the exit hole there. Goes out there. And out here. Now if I go back to this picture again. So when the pump is fitted, now this is the bolted interface here. You can see it exiting out there and back into the tank cyclone. You can actually see the pipe going up there and into the cyclone. It goes into the perimeter of the cyclone, swirls around, separated, and can drop down, and the air is vented. So let me have a glance at the time. Yeah, let's break it now. 25 minutes exactly. So I shall talk to you in a second. Okay, so now, as mentioned, they're the basic scavenge systems. The sump girdle, which we'll touch on in a minute, the heads are done, how it all works, how it's separated, how it gets back to the tank, and you know the general theory of dry sump systems in a Formula One engine or any engine. But you know, just minimize the parts if you're designing one. That's all I'd say, and try not to have the head returns coming down onto the crankshaft because you will sap power. But getting back to the original question, why or how the timing chest oil, how this doesn't fill up with oil inside here, because all these gears are getting oiled, as you know. You've seen that in the previous video with the little squirters here and there, and just general flow from everything. So let's turn off that timing cover again and turn on the sump, which is somewhere right here. What else can we turn off? Just so that it's not so taxing on graphics. Turn off the end plate as well. Turn that off. Turn off the crank, which is down at the bottom as an imported part from memory. Yeah, right. So this will be the timing chest, as you know, where all the gears live. And if I go up to the top again and turn on the timing cover, you'll see the gap. So you can see the gap there where all the gears would sit. It would be between that face and this face here. So it's approximately about 15 mil. Let's measure it while we're here. From there to there, 12 mil. So it's a half an inch, 12.7 for you living in stateside. So again, it was all done internally, how they evacuated the timing chest area. And it's with one tiny drilling, which was fairly crazy to machine. And it is this drilling here. Now it's not in the lowest part, but that doesn't really matter because there'd be a lot of turbulence in here, which would spin the oil around anyway. So eventually it would end up here in this area. And as you can see, the radii on different parts, you know, it's all kind of designed to flow, apart from this one, back into this drilling here, which is drilled at an angle. So if we follow that drilling in CAD, which is going to be a little bit difficult, but we will manage. So if I do a section analysis on this surface here and skip down to where that is, you can see it's crazy. It's drilled at an angle across here into one of the bolts which secures the girdle onto the engine. Now I know having oil circulating around a bolt isn't unusual. Like going back again to the Mark 1 Golf, I think the cylinder head was oiled from, was it the head bolt, the rear head bolt on number 4? No, it wasn't. It was the front head bolt on number 3. The oil was sent up from the oil pump. It went around the cylinder head bolt and then went around the counter bore or the clearance bore of the cylinder head bolt into the tappet or the rocker gallery. Now, as you know, any of you guys that worked on Volkswagens, if you don't tighten that bolt, you have no oil pressure. So make sure your cylinder head bolts are tight if you've got a Golf, because the oil will just come out of that interface there. But on this, it's similar. As said, the suction is here out of the timing chest through this drilling into this counter bore. Okay, now if I go down from that, or up, I can't remember. Yeah, it's up. So it exits again from around the bolt head counter bore down here. If I go down again, I'll be able to follow that drilling. Actually, I'll zoom in a bit. I have more resolution. Yeah, so if I go down, now this drilling was not a drilling, it was cored with a ceramic core, as we spoke about in the last video, the second half of the last video, because it's a tiny core. It goes down there, keeps going down, then it goes across. It goes across here like this, goes around here, it avoids a feature there, which I can't remember, I'll show you in a minute, and it comes out here onto this boss counter bore, which on the manifold here, if I turn it the right way, it enters here, so that would fix onto there. So you can see the oil path in here, down around the bolt head, down here, in through all this, in here and out here, and get scavenged with the zone port, which is here. Now again, just to go through these ports, these are from the cylinder heads, so they have their own windows or ports, and again their own windows on the roots blowers here. So this one would enter here, it has its own section that's communal to this one. This one comes in here, turns kind of tight, and that's its own one there. This one here is this scavenge section here, which is on the sump girdle. Now I just want to check why that did take a bend there, because I know I scanned this with great difficulty and I'm pretty sure it's right. So let's have a look why it goes around there. Let's just come up in that section. I think it's just avoiding this boss here, that's all. So yeah, fairly crazy. This was if I just cancel out of that, come on Fusion, don't die. The weighting. So this is a counterbore here, as I said. Now this counterbore was plugged with a threaded bung, just because this has to be oil tight. Once you enter the bolt in here, you put in the bung, so this is oil tight or vacuum tight, because this has been sucked out here. And I'll flip that around and show you the bolt hole here. So it's a really deep counterbore. These ones are fairly shallow. This one is really deep, and you can see the oil ports entering to either side there. And this one here goes off, as I said, and then the bung gets threaded in here, and that blocks off that. Now there's no threads drawn on this model. Like, I know what size, by measuring a dimension, I know what size threads should be. So there's no threads drawn, because it just makes it too heavy on CAD. And once you draw a thread on on a CAD file, as you'll know, if you want to machine that part again, it's extremely hard to pick up a dimension off a thread, because it starts off like in a spiral, and it won't give you a true dimension. Like if I clicked on that now, which is 19 millimeters for a needle bearing, if you had that threaded, it'd just be a weird finish here, and you wouldn't get an ID on it, which is 19 mil down here. Now again, this is the timing chest as mentioned. All these bosses here, there's needle bearings to carry different shafts. Now you've all known, this is a needle bearing out of, I think, the water pump over here. So these sit in there. There's a small little hole here which lets the oil in, and on the timing chest itself there's a little tiny oil way here which lets the oil in, and it runs down here and it feeds the needle bearing with oil. So that's how they're all oiled. There's quite a few of them. Again, this one is the same. This one hasn't a run-in area. Instead, they put a fairly heavy chamfer on it just to collect the oil here so that it will pool and again run into the needle bearing and oil that. And the same for the water pump needle bearing feed. Over here, runs in a long hole there, and it oils the bearing. Now, as I said, I'm going to get into all that again. I don't want to touch on it now because that's kind of the pressure side, not the scavenge side. But the last thing in this video is this part, which is a mystery part, or was many years ago, but obviously I know what it is now. So let me show you where that goes. Let's do a section. I want to turn on the crank again. Which is there. Now let's section it back to where are we? I want to try and go bottom dead center if I can, just to show the maximum or the minimum clearance. Yeah, the reader one is on bottom dead center. So let's do a section there from here all the way back. Actually, let's just look at one thing first. Now I know it's on the pressure side, but it's worth showing you. So you can see this weird snake-like squiggle here, and you're probably wondering why did they do that. Well, I didn't know either until I scanned the part and measured it. So as you know, there's oilways in here which run all the way along, which we spoke about in a previous video. They run all the way here, and they're locations for oil squirters to bolt on to cool the pistons, which I actually have here. You should be able to see them, hopefully, somewhere. Yeah. So if we just zoom in. Now again, this is the pressure side, which I want to not really do in this video. But that's where the squirters bolt. Just let me have a glance and see, can you see that? You can. So this is one squirter which bolts onto that area, 2 M4s, and the oil comes out here. Like, the clearances are very small, so it's right up there underneath the crown of the piston, squirting in oil there. So that's what the squirter looks like. Let's go back to the CAD and back to this area here. Now, because they couldn't drop a drilling down here into that oilway, because there's a port there for the scavenge system, they actually had to machine this weird oilway here and drop a drilling down here into that oilway, because otherwise, if they drill down here, it'd just go into nowhere, you know. So just to show you that, on this area here, and if I go in here, hopefully you'll see a drop drilling there. If you don't, yeah, magic. So you can see where they dropped the drilling in here to get access to this oilway here, which oils the piston squirter. Again, we've covered this before, but this would get blocked off. This is an access drilling here. This would get blocked here then with just a divot and swaged in. But that's why that weird squiggle is there, just in case you're wondering. So getting back to this part, while Fusion is thinking about life, this part came up a long time ago for sale, and it was marked that it was from the TJ engine. It was before I had bought the TJ engine, and I had no idea what it was from. And until I got the TJ engine, and probably about, I think, 4 months after that, there was 5 of them. Did I figure out where they were actually for? Because it's a pretty strange looking part, as you can tell. But after many hours of looking on the engine, like when you get an engine this engine I bought not assembled, so you get about 10 boxes of parts which aren't assembled. They're all, you know, they're all fit for race, but it can be daunting enough. And I didn't buy the build sheet of Cosworth, because the build sheet of Cosworth was, at the time, I think approximately €2,000 for a folder on how to put the engine together. So that's a lot of cash for a few pages. Well, not a few pages, but you know what I mean. But finally I figured out where it goes, and I'll show you that now. And it's very important in a dry sump system if you're designing one. So let's do a section analysis once again, and the last one into there, and let's put it straight onto the camera and zoom things in. Alrighty, so this is the crankshaft, this is the girdle, these are the oil ways, we spoke about them before. This is the port out, which will be here, that'll go there, so it's sucking out there. And this part here, which is like a door stop, a very expensive door stop, bolts on right there. So the purpose of this part, as you can see in the bottom, it's nicely machined, 3D machining. It bolts on there, and its purpose is to catch the oil that's flying around here. Obviously the crank turns clockwise, so it catches the oil here, it stops it from whirling around continuously. Like a lot of these, I get sent a lot of designs for dry sump systems, and they're normally just a sheet metal sump with a piece of, let's call it box iron, with the top side cut off the box iron, and they expect the oil then to just... Okay, so sorry about that, the phone ran out of storage. So I was saying a lot of designs that get sent, it's box iron here, the top cut off. They expect the oil to just, flow in here, stay in that section and get sucked out. Now there would be filters in this section here just to catch big material, which you can see in this scavenged rotor here. It sucked in some sort of foreign object which was fairly big looking at it. So I'd probably say these are spares. They came from an engine that was wrote off, I would imagine, after spitting out something that large. But you would put filters in this drop section here just to catch anything before it gets into those. But getting back to some designs that get sent, it's supposed to sit there happy and not get brought up by the crank again, which it does. So you really want it as smooth as possible. Other designs that you sometimes get shown, that have a secondary sheet metal part above it here with louvers cutting it, and again expecting the oil to drop down through the louvers, but that doesn't really happen. It just gets picked up again and has no real clear way of getting out into the Scavenge system. So if you are designing one, you've got a perfect curve here, or two curves, radius shape. Use that and just put in a step or a ledge that will stop the oil in its tracks and has to be hoovered in. It has to stop there. But yeah, I think that fairly covers this video. Again, this part, like you can see how tight tolerances are. These clearances here are for the conrods to pass by, so there's nothing to spare in the engine. So yeah, hopefully that all makes sense. So as I said, the next episode or a few episodes time, I'm going to do one on the pressure oiling system, just to cover now we've covered the crank, just to cover the heads and a few other parts. But I think that is that. Episode 11, so I shall see you in 12, and Easter's coming up, so if I forget to say it again, have a good Easter and take some time off, which hopefully I'll get a chance to do. Good luck.